All right, this one, we have a reflection over the line y equals x. The red line here represents y equals x. Okay, and we know this because y equals x, if we were to write out that equation, the the coefficient in front of x, that number that's usually in front of x, represents the slope. Well, there really isn't one there, but remember, technically there's a 1 there. Okay, so this has a slope of 1. In other words, this line will go over 1, up 1. Okay, that's where you get the slope of that line. And the reason I start at 0 when I go to graph this line is because technically its y-intercept here is plus 0. That's why there's nothing written there. Like usually you have like a plus 5. Okay, so it starts at 0 on the y-axis, and then we just go up 1 over 1 in a positive fashion. Okay, now you might run into y equals negative x, which is very similar to this line, but instead of going up 1 over 1 positive, so it gives it up, an upward slope here. Remember, we read a line left to right. Okay, as it goes left to right, y equals negative x will go down like that. All right, so for this one, though, we're going to do y equals x. So what does it look like when we reflect over y equals x? Well, remember, I said we had to come straight across that line. And we also have to make sure that whatever the distance is over here is also the distance over here. So I personally like to visually just do the representation of reflecting across it by doing that straight line across like I just did. I find like if you have the graph, it's really not that bad. So in other words, like if we're counting the number of spaces, we have 1.5 spaces over here. So I go 1.5 spaces on this, and that's where E prime would fall. Okay. Now if you look at it, okay, this original coordinate for E was 0, 3. Okay. And the new coordinate for E was 3, 0. All right. And so there are rules that you can follow. I'm sure Mr. Oz went over them in his videos that tell you exactly how to deal with these. So if you look at these two coordinates, the rule here would be the x and the y are switching. And that's exactly what will happen for D also. D currently is 0, 1, so it would become 1, 0. We could also still use that line that goes across, make it perpendicular. Oh, it's a half a space on each side. So we did it right. This one was perpendicular. It was 1.5 diagonal spaces across on each side. So you can use the line or you can use the rules. It's up to you. So C. C is -2, 4. Okay, so that's the original coordinate. So if we flip that around, it would become 4, -2. So there would be our C prime. All right, and if we connect those points, I'm just going to do it by hand here real quick. Okay, you get the triangle reflected across that line. Mine's not very perfect, but it doesn't have to be. It gets the point across. Okay, now the rule does differ if you're reflecting over y equals negative x. Remember, y equals negative x is the one that goes the other way, like this. Okay, that's y equals negative x. Now, the x and the y still switch places in the coordinate value, but they also change signs. So, like for C, if I was to reflect that over y equals negative x, my new line in there, isn't that beautiful? Okay, but that one would become -4, 2. Okay, so it switches places and signs. Okay, so just be aware that's the rule if you're flipping over y equals negative x. Or you can just do it visually by drawing those diagonal lines across. All right, good luck.